Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about New Glenn versus Starship. And this is the closing year of 2025. So what is going on? Let's dive deep into it. Now, before you understand the current mess that USA is in right now, you have to understand what exactly is the problem. Well, problem is space shuttle. Space shuttle was not designed as it should have been, as in like it's supposed to be beautiful. It became cuckoo, simply because too many governmental agency had too many conflicting requirement, and they're just like, no, I want this capability, and that it became just behemoth of thing, and it was bad. As in like how bad? Well, here's the deal. In whole Apollo era, only one time accident happened, as in like death, as in like loss of life. That was Apollo 1 on ground, not on rocket, on ground. And what happened when they actually did all the mission? Only one incident happened. That was Apollo 13, where basically hydrogen fuel cell, basically oxygen, supercritical oxygen tank went kaboom. And what happened after that? Yeah, mission loss. But people survived, as in they could not land on the moon, but they returned. So all things considered, Apollo had zero casualty, like actual rocket wise, zero casualty, and missions were done, only one had fault. So compare that to space shuttle. Here's the people, basically the administration of NASA convinced themselves that space shuttle has, like, 1 in a million chance of failure. Engineers on the back end, they were like, bro, you'll be lucky to get 1:100. And ironically, unfortunately, because be mindful, this number like 1:100 happened after the first Challenger disaster. That happened due to miscommunication, and be mindful, they're supposed to be cancelled. Somebody was trying to raise alarm, like they did not have the proper procedures on play. That's like, hey, if somebody is screaming that your O-ring is out of spec because of the temperature, listen to that guy. They did not, and it went boom. And after that time, they did a lot of investigation, and turns out the engineers' internal database was like, hey, 1:100. Here's the funny thing: space shuttle flew less than 200 times. It went a boom at 2 times, exactly as engineers predicted. So it messed up. Let that be very clear. Like space shuttle as a project, it failed to deliver the cadence that they were expecting. They were expecting 2 launches a month. They barely got 2 launches a year. They were expecting it to be cheap. It was more expensive than basically Saturn V. They were like, they expected it to be safe. It kaputted 14 astronauts. So yeah, it was not good. It effed up America. Now here's the deal. This is a time where nobody was interested in space. And be mindful, space shuttle's poor performance also pissed a lot of people off. So nation, as in like, let's just say president, Congress, as in the people in that white building, and NASA, they all went into limbo, meaning there was no clear-cut goal. There was not like, okay, this is who we are, this is what we're gonna do, this is how we're gonna do it. It was just lol. Now, in that years, be mindful, this is very early on. This time China was not a threat. China was nowhere near as big a deal as it is now. So they were like, people was not that interested. NASA was not very clear what they have to do. Congress was like, so everything was just in a mess. And again, you can understand how messy this was. Like, Obama is like, I'm gonna cancel Constellation. Constellation, Control C, Control V, space shuttle parts. Like, Congress is like, no, you cannot cancel it. But he's the president. So they're like, okay, we're gonna kaput the public and make SLS, burn public money. Oh yeah. Yeah. It was a limbo. It's a mess. And then ISS retirement start to happen. Now, here's the deal. Why ISS is quote unquote wearing down? Here's the deal. It is going through way too many thermal expansion and contraction. A building on Earth goes through thermal heating and cooling in a day once. So one cycle, one day, one night. In low Earth orbit, day, night, day, night, day, night, day, night. It's way too much. And not to mention, every time you're docking something, you are putting some load into it, and there is no gravity anchoring you. So all the damage, like the oomph, the shock actually goes through the whole structure. And that's why all the engineering, all the exercising equipment has to be floated, because again, if they do not do that, it will shock so much that, as in shake so much, the solar wings will flirt like this. So basically, it's reaching its fatigue limit, meaning it's astronauts inside the ISS is spending a lot of time into repairing the ISS rather than using the ISS. So that retirement is happening, and again, timing could not be worse. Why? Because they were in limbo. Now this deadline appear, so they're stuck. And this is where America, NASA, administration, whatever you want to call it, they smoked something bad. Basically, the idea was not to make ISS Mark 2.0, basically a better space station. The idea was to make something grander than this. Basically, make a space station on the moon. Now, if that triggered a red alert in your brain, Good, that means you have a brain. This is the dumbest idea theoretically possible. So the idea is you're going to have a space station that is on the moon. Now here's the deal. ISS was put into low Earth orbit for one very specific reason. It's inside the Van Allen radiation belt. Once you are outside of it, you are exposed to much higher radiation. Now, let's say you want to go to the moon. Where is the best place to be on the moon? It is on the moon. Why? Well, assume there is a sphere. Let's say it's celestial sphere. You are inside that sphere. We have universe around us. It's pumping radiation into us, and that's a sphere. You are standing. Which is the worst place to stand? In a space station. Why? Because let's say you are getting 1x of doses. If you go into basically lunar surface, there is moon below you, the best insulation there is. So you lose 50% because half of the sphere is cut because there is moon below you. So they are literally exposing people to unnecessary load of radiation for some reason. And you're like, okay, what if we're shielding? Bro, we can't do shielding enough for that sort of long-term exposure. And again, it's a cumulative damage. Basically, it's not that if astronauts are there, they're going to be kaput. It's just that, like, why? Why you are exposing them to extra radiation? Why? Like, they're already best of the brightest. It's unwise idea to like slowly give them cancer that after they retire, after people, they got out of, like when they are like, 70s and all of them are like, oh, I have this cancer, I have that cancer. So it's really dumb. So, and again, that's a scientific level. It cannot be engineered away. You cannot put enough shielding on it to match moon. So it's a really bad idea. And again, it's such a bad idea. They're trying to repackage it so many times. The early name was Deep Space Gateway. Then it got like, yeah, that's a shitty name. Like a LOPG, ultra shitty name. Then they're like, okay, right now Lunar Gateway. They might rename it again to de-shitify it, but it's a shitty idea. And again, that itself was like, bad, but then they're like, okay, what if we made it extra bad? So the idea is, basically near rectilinear halo orbit. Now, why that orbit is bad? It's high energy orbit, meaning can you do it? Of course, but it is not a stable system. As in, NASA literally launched a small satellite just to test can we actually do it or not. And you're like, wait, didn't we do orbit on Apollo? Yes, we did. It was a simpler orbit, logical orbit, but this time is cocaine orbit. Like, can it be done? Of course it can be done. They're like, no, but it will maintain communication. Have a CubeSat. It's cheap. So it's like it is really bad. It's almost like the same damage that destroyed Space Shuttle is the same thing. It's like everybody's like, okay, what if it did that? What if it did that? It's like, what if it's logical? Basically, if it's logical, it should not be there. Like, there is no reason to put humans in unnecessary radiation hazard. And on top of that, the another aspect is it's wasteful with delta V. That's why Apollo did not do this sort of orbit. That time they did not have CubeSat technology, but they still knew that doing a simpler orbit is much simpler. And then why this is not being cancelled? Well, it's a who's mess, so to say. So there is NASA, there is ESA, there is JAXA, there is CSA, Canadian Space Agency, and all of them are stuck into it. So nobody can pull out. It's like, okay, if I pull out, what will they say? So everybody is carrying forward this shit. So it's bad. Let's just be very clear about that. Now, at this point in time, there is no rocket that can do this because this was assumed to be output of SLS. SLS is behind schedule and it cannot actually do this. It's just like, no, it cannot be done. Again, if government tried to do it, $2 to $3 billion per launch, yeah, no. So that is there. Now, unfortunately or fortunately, depending how you see it, China was not on that smoking train. So they were not smoking. They were like, hey, what is our aim? Land people on the moon. What is the most energy efficient way of doing it? Go to the moon. So they are doing that. So fundamentally, if NASA wants to have a rocket that works almost like Apollo, even with lower tonnage or higher tonnage, it cannot be done if they have this sort of, what if we dock there? Yeah, that cannot be done. It has to be lunar orbit, a low lunar orbit or something very simple. It cannot be this sort of weird cocaine diagram. Now again, it can be done. It's just that why? If your aim is to lunar surface, go to the lunar surface. Reduce radiation exposure of your astronauts. So fundamentally, they do not have any rocket. There is not a single rocket that can do this as of now. That's why refueling is such an important thing. They could not do it without refueling, even though we did lunar landing without refueling, and China is doing that. The next best thing after, direct launch is docking 2 spacecraft in space and going. But this is so stupid, it cannot even do that. It has to have like 3-4 refueling or maybe a tanker in lunar orbit itself to do this. It's stupid. And penalty, US A, Artemis, is in limbo. And because of this whole situation, it's really unclear who is going to do, what they're going to do, when they're going to do it. Everything is a mess. Now, there is one hope, ray of hope, that once NASA realized they are kaput and this will not be done on time, because their deadline is that under no circumstances the contractors that are in ISS should go without work, because they will leave the country. So they have to make sure that, and again, that's the reason why they say, like, basically you can go from high workload to low workload. You cannot go from high workload to zero workload, because when you need to restart it, let's say it takes 3 more years to get the next space station ready, they won't be there. So they have to make sure there is continuation. Company can shrink, but company cannot go offline. So commercial station project was expedited for this exact reason: get something off the ground. So be it Axiom, and there are some other companies that are also trying to bid on it. The idea is have something ready, even if it's like, not fully fledged at ISS. Have something, anything better than going offline. So you can understand that problem is a messy. And China is clear. It's like, bro, we need to go to the moon, the end. And NASA is like, what if SLS worked? It's like, it does not. No, but we designed a plan for that. No, but it does not exist. It's not real. SLS is not ready. It's like, no, but what if we smoked cocaine? It's like, what if we got ESA to smoke it, and JAXA to smoke it, and CSA to smoke it, and everybody's like, shit. So that's the problem. So let's understand the best result of space shuttle, SpaceX. It was founded by Elon Musk in 14 March 2002. Now, Falcon 1, the first rocket they designed, which had one rocket engine in the first stage, this puppy, that first time they launched it in 24 March 2006, and it went kaboom. It went kaboom 3 times. And the fourth try, that was in September 2008, they successfully deployed payload into orbit. So it was ready to go into the big leagues. So their plan was Falcon 1, Falcon 5, Falcon 9. And they were like, hey, we do not need Falcon 5, kaput Falcon 5. Falcon 9 was built. That was one stage. The first launch happened on 4/06/2010. That was the first time they launched it. It worked. And the first time they actually started to deliver, that was Dragon to ISS, basically this puppy, Dragon going to ISS. And that was a big deal because that was the contract. That happened on 22 May 2012. Again, that was just a docking rehearsal. The first time cargo resupply happened, basically after the grounding of space shuttle, America gaining the ability to send things to ISS, that was done. Now, again, there was other craft, but this was like something that could grow into something big. So that happened on October 2012. This is the time where NASA finally starts to grow back its wing. It's like, hey, we have Cygnus craft, we have this, and we have this. Like, we are slowly getting back to it. And after this time, Falcon Heavy launch was done, this puppy, basically. And this was first launch 06 February 2018. I was in Bangalore. I watched it live when through the basically rooster in space. And it was cool. It was cool. No denying that. And after that first Crew Dragon mission happened, that was in May 2020. This is the time where they finally got their wings, as in NASA finally can carry astronauts on its own without going to Russia. So that was a very momentous deal. Like basically the whole mess of space shuttle can be replaced, and they can finally, instead of sending people into washing machine known as Soyuz, they can send it into something that is a small coupe car, so to say. I'm like, you should really see how those 3 astronauts are there. It's like, bro, like it's a washing machine that is there. And you have to understand, all of the design fundamental of Falcon 9 rocket is not designed for the best rocket it can be, because you have to know SpaceX did not had money at that time. So they designed the rocket to be so thin in diameter, so it can go below the road bridges, as in they should be able to transport it normal road without requiring excessive fees, excessive vehicles, all of that, basically to reduce running cost and all that. So commercial resupply services was the key. The rocket supposed to be only good for taking the stuff, dumping into ISS. That was the first point. That's the only point where NASA was like, okay, we're going to give you money if you do this. And again, once they achieved this, once they refined it, then they started to experiment. It's like, okay, what if we make the booster reusable? And it took them a lot of try, like 5 tries to get the booster landing done correctly. And after that, few tries where it became normal. After that, where they became like, okay, now we can reuse the booster 20 times. So commercial resupply service was the key. And even Falcon Heavy, it's a basically Control-C, Control-V of Falcon 9. Basically, it literally has 2 extra Falcon 9 core. They never designed any brand new rocket. It's like, okay, SpaceX, tight budget SpaceX, and there is no blank check design. Starship is the only blank check design where it's like, okay, we have the money, we have the resources, and we do not have constraints. make a big ass rocket. So they are making the big ass rocket. So this is SpaceX. And you have to understand, there is a world before Falcon 9 and there is a world after Falcon 9. It's like an iPhone moment of rockets. It is undeniably the most practical, logical, highest cadence ever achieved rocket that is actually, like, here, real. So amazing work till Falcon 9 series. Falcon Heavy is also cool. Now we come to Blue Origin. Now, Blue Origin was created by a guy known as Money, known as Jeff Bezos, and that was created on 8th September 2000. Now, like, wait a minute, isn't that before SpaceX? Yes. And first time they flew their first suborbital rocket, that was Goddard, on 13 November 2006. So far, not so bad, but the first suborbital human flight, which, mind you, suborbital only, it took 2021. They were very behind schedule. Although, let that be very clear, they were very thorough in their approach from day one. It's like, very thorough, day by day, brick by brick. And it worked. And again, you have to respect Jeff Bezos' balls, where it's like, no, this is my rocket. I'm going to ride on this goddamn rocket. It's like, damn. Like, talk about like whatever you want to talk about. Like, but that takes balls. It's like, this is my rocket. I'm going to fly on the damn thing. So that happened. And slowly, it took, they are behind schedule by 10 years, but slowly they finally started to deliver on the promise. Promise was a BE-4 engine, because you have to understand, during 2014 of annexation of Crimea, Russia and USA did not make love to each other. So they're like, hey, Russia was like, no, we're not going to give you any engine. America is like, no, we're not going to buy any engine. And then America realized, oh, we do not have any engines. That's how bad Space Shuttle was. So they're like, okay, please, somebody make engines. A lot of company tried. BE-4 was the only one that was delivered. I think one more engine was there. If you know the name, write it down. So it was delivered to ULA. So ULA no longer need to rely on the old stock of Soviet engines. So they're like, okay, brand new engine. And it did reach orbit. Let that be very clear. If you compare BE-4 to Raptor, BE-4 actually reached orbit as of now, end of 2025. So that is that happened on 8 January 2024, as in payload deployed into orbit. Done, go home. So that happened. That's a good thing. That's like, hey, you are behind schedule, but at least your engine is actually going to orbit. That's cool. And then the first New Glenn launch, which again super behind schedule, but did happen on 16 January 2025, starting of this year. And it worked. It worked. They launched a rocket. It deployed the payload into orbit. That's good. That is good for first orbital class rocket of a company directly going from, yeah, we're going to launch it and it's going to go to orbit. That is good. The only thing they failed is landing, which, mind you, nobody cares. The rocket's first job is to deploy payload into orbit. After that, you worry about whether you land it or not. You can have like, okay, we have a perfect landing. Did you deploy payload into orbit? No, does not matter. So first was surprisingly good, and they flexed again. And a New Glenn 2 happened. That successfully landed. Basically, they landed this puppy on 13 November 2025. Basically, second launch in 2025. And they did everything they did. And this time, this was a paid mission. Let that sink in. This is a paid mission. As in, somebody gave them money, $20 million. And it's like, hey, throw this small satellites to Mars. And they did. Done. Done. It's done. It's not going to happen. It's done. Go home. So they are flexing. Now here's the deal. How does philosophy of basically Blue Origin compares to SpaceX? Here's the deal. Jeff Bezos is money. He does not count money. He is money. So that's why the rocket diameter, even though it's designed so early on, it's so big. Another aspect, it was designed for geostationary satellite market. Why? You have to understand, this is early 2000. At that point in time, Ariane is the darling of the world. Everybody's like, Ariane is the puppy. Because again, how do you launch James Webb Space Telescope? Ariane. How do you launch super large satellites for geostationary? Ariane. Everything. Every Tom, Dick, and Ariane. So they were directly targeting on that mission. And plus, military contracts. Military satellites are generally heavier, and they do want to be sent to some specific orbit that requires a lot of oomph. That's why the second stage on this puppy has hydrogen burning engines. It is less powerful but more efficient. Benefit, higher delta V. Benefit, the ton, like let's just say they have 45 ton to low Earth orbit, it does not drop off very quickly. While Falcon 9, it was designed as a low Earth orbit vehicle, it is a very good low Earth orbit vehicle. This is a bit higher than that. So it can dump 13 ton to basically geostationary orbit. That is significant. That's not big, that's significant. To give you a context, the heaviest payload, again, unclassified payload, that Falcon Heavy has carried, it's around 7 ton, so to say. I think Arabsat or something like that. So this is a big rocket. And The biggest benefit, compare this to Falcon Heavy, this has a big fairing and this has a clean sheet design, as in like they're not trying to reuse the second stage. So it has the ability to go toe to toe with Falcon Heavy and win. Like simply because it's a clean sheet design. And again, diameter matters. Because again, if you, let's say you want to launch a space station module, what do you need? What is the biggest thing you need? Large volume. This puppy is like, I got the volume, man. And again, I have heard multiple times SpaceX is gonna redesign a new fairing. It has never come to pass, but I think mostly because they are diverting all the resources to Starship, and it makes sense. It's like if Starship works, they do not have to worry about it. So that is there. So this is SpaceX and this is Blue Origin, and the guy has balls. I have to respect that. Now we come to the heavy lift market, which is going on right now. Now, because NASA got trolled by SLS and China is moving fast, it creates a very sticky situation. And Artemis now has contract because SLS cannot deliver, like flat out. The original plan was SLS go the end. It's like SLS hope. So now SpaceX got the benefit of a very successful rocket company, very successful rocket Falcon 9, and they got a clean slate contract and they designed Starship. Now Starship is not the first design. First design was Interplanetary Transport System, which was like a full joint design, 300-ton to low Earth orbit, full carbon fiber, bonkers amount of engine, 12-meter diameter. They actually built tanks on it. Let that be very clear. They actually built the hardware for it. And then they're like, yeah, this is too much cocaine. Let's come down. And they're like, okay, let's drop it down to 9 meters. Good decision. Let's shift down from carbon fiber to stainless steel. Bad decision. And I have no idea how so many people are convinced. It's like, oh, stainless steel allows you to do re-entry. It's like, you know, the fastest object that ever re-entered, which had a human inside? Apollo. What it was made out of? Aluminum. Soyuz. Very trustworthy, reliable system. What is made out of? Aluminum. Space shuttle carried people home. Only time its heat shield failed is because there was a giant object, a 2-kilogram foam block going at Mach speed at it, and carbon-carbon structure, which was not designed to tank a heat. Which again, the original space shuttle design was to put it on top of rockets, so falling debris do not cause that damage. Tragedy. So understand that there is never a scenario where heat shields require this sort of weird thing where it's like, okay, we're gonna snap it on. It's like, no, you glue it on. And again, your own edges, your own wing edges are glued on. Why don't you just glue all these things? And you're like, okay, it requires a lot of time in disassembly. Have an automated system. It's like that is a really bad design. But again, this is the same guy who smoked enough where it's like, okay, what if I take Robert Goddard ideas and I repackage it and call it Hyperloop? People will smoke cocaine with me. And they did, unfortunately. I was like, what if I drill a tunnel? People are like, whoa, are you making a road tunnel? No. Are you making a metro? No. What are you making? You're making cocaine. It's called Boring Company. And people burnt money on it. So yeah, if you think, oh, anything coming out of Elon Musk is great, I'm like, I'm sorry, man. Like, pass the joint to me. So, flat out. He makes a lot of promises, which again, 300 ton and then is like 100 ton to low Earth orbit. Okay, cool. Money making supposed to happen because of Starlink. That is another project that could work. If they actually start to deploy Starlink in large enough number, that could make some serious money. No denying that. And so far, it's not looking good. Let that be very clear. Compare Starship to Falcon rockets. It's not looking good. You have to deploy a payload into orbit. After that, you can do whatever you want. It's like, oh, we catch the rocket. It does not matter. Did the rocket deploy a payload into orbit? Yes or no? Because here's the deal. If it was not SpaceX, they would be literally in court for litigation because it's like, dude, how can you charge for Artemis when your original V1 design was only 15 ton? This is not me. This is SpaceX. This is Elon Musk. So V2 was 35 ton. V3 magically will be 100 ton. Oh, by the way, this is V3 that just went to boom right now. Now, why the rocket is having this much issue? Original design of Raptor was designed for interplanetary transport, which was a carbon fiber rocket with a giant surface area to volume ratio. First, you lost most of that surface area to volume ratio, shrinking it. That's bad. Then you shifted down from carbon fiber. If they had switched down to lithium aluminum alloy, which is the construction of almost all rocket systems, including Falcon 9, they would have survived. They jumped down to stainless steel. That is the bad part. Engines are not performing. How do I know that engines are? They keep upgrading the engines. They did not have to do that. No company does engine upgrade mid-design, where it's like, okay, we launch it, we send it to orbit, and we are happy with it, then they tune it. Not like, oh, it's not working. Okay, let's make V2. Let's make V3. And again, right now, I'm not joking. There are a lot of people saying that V4 design is underworked. That simply means V3 also does not have the oomph required to do that. And most likely it is true that it does not have the oomph, because again, V1 was here, V3 2 was here. V3 can only be a bit better. You have reaching the theoretical maximum. But what can jump going from V2 to V3 is engines are lighter. So that should be beneficial. But again, realistically, designs is too goddamn heavy. Hope that V3 is way too optimized, way too lightweight to actually do it. But again, doubtful. Doubtful you can directly jump from 35 ton to 100 ton. Again, it could happen. Let's hope for it. But in the 3 to 4 years time needed, that's the difficult part. And again, 11 tries have happened. This has exploded. So let's see. So promise 100 ton to low Earth orbit, they should be able to do that. Although the biggest hurdle, that so far is minor inconvenience. The major issue is that they require refueling for lunar system, and not one refueling, multiple. The most optimistic design is 11, the realistic one are 15, the worst case scenario is 22. That's not happening. That is SLS with extra strip. That is not happening. Let that be very clear. If they actually say that, yeah, that's not happening. 1 or 2 mission, and then they're like, nope, they'll just no problem. Because again, inherently you just made a low Earth orbit rocket, and you're forcing it to do, deep space object. Just have a third stage. Like, as in, like, here's the deal. How do you do better than, Saturn V? All you do, you deploy 100 ton. And you do another 100 ton kick stage, 100 ton, basically the lunar stuff, basically lunar landing, lunar ascent module. And how do you transport the astronaut? You transfer it to Dragon. Exactly the same design they do. And how many launches you have to do? 3. Done. Go home. No refueling required. No, I'm not even joking. There are rumors that apparently they have to launch, then have a tanker craft, refuel the tanker craft, then launch the lunar system, then the tanker craft will refuel it. What are they smoking? So that is there, flat out. It's not happening. Refueling for moon, it's not happening in long term. At best case scenario, they will get 2 or 3 tries, or they will change the design. So, and then we come to New Glenn. Now, New Glenn is way too late. It could have been like, sweet spot, but it is too late. So that is there. So, but in principle, they can scale up the design and they can go to the moon. And their third mission is bold. Whatever you call about it, the dude got balls. That's the third mission. Land on moon. Actual craft on moon. Again, if you compare Starship with this, and if assuming this happens in February 2026 and they actually do this, there is no discussion after that. You can have like, oh, we're going to land 500 tons. It's like, yeah, there is an urgency. I'll discuss more about that, but there is an urgency. That will win flat out because of the urgency. And time is of the essence. Basically, we are not in a stage, NASA is not in a stage where late and great will not do. Basically, yeah, oh, we are late, but we are great. Yeah, it's not the right time. It's like you are in a hospital, certain things have to be expedited. Landing on moon has to be expedited. Even though it could be worse than what Apollo crew did, it still would be better to do that rather than not do it. So that is there. And NASA will be forced to let go of Lunar Gateway because again, SLS is trolled. So what will happen? Well, that depends on how quickly the commercial space station comes online. If it comes online quickly, they can quietly close it down. And Starship has to deploy payloads into orbit in order to get that, and they have to sort out and again, this is the reason why NASA and SpaceX is like not making love anymore. It's like, bro, by this year you should have sorted the refueling. And again, if you sell someone, it's like, oh, we're gonna refuel it 20 times, they expect you to do it by like 5-6 times by now. It's like, yeah, and timeline was 2024, came and went long ago. So that is there. And New Glenn has to land on the moon to get even a chance into it. So can they do this? I do not know. But again, if they pull it off, it would be exactly like how we had like Apollo versus basically so USSR project. So heavy lift rocket, basically if you compare Falcon 9 development with Starship development, it's just copium. It's just people trying to cope with it. It's like, oh, this is because of this. It's like, no, it's a bad design. If you have to keep changing the design, it's a bad design. You did not make a design and launched it and got everything sorted, and then it's like, okay, let's make it better. You're sorting the design because it's not going to orbit. 15 ton, 35 ton, that's not useful. Especially when you have Falcon Heavy. Especially when you have Blue Origin 45 ton to low Earth orbit. That is not good. Now, let's understand the urgency part. Now, China is on track. Let that be very clear. China does have this advantage that is like, this is what we're going to do. This is how we're going to do it at the end. They have that. They are very clear. And what does it mean? That simply means taikonauts could walk on moon as quickly as 2030. And it's a very high likelihood. Is it guaranteed? Of course not. Some world event could happen, or rocket could go boom, or some project issues can happen. But likelihood is very high that 2030, they have taikonaut on moon. So USA needs something that is ready, not something that is going to be, something that is ready in the time frame of 2026 and 2029. Unfortunately, the answer is nothing is that ready yet. Nothing, not even Blue Origin, not even Rocket Lab, not even SLS, nothing. SLS could force it, but again, because they are conjuncting basically this system, what you call Lunar Gateway, and the weird landing system that's supposed to work with Lunar Gateway, yeah, that is creating a mess. So it's very difficult to get things sorted by 2026 and 2029. So that is there. Now, Starship, maybe, let that be very clear. Knock on wood, let's just say, knock on wood, that design V4 or V5 is finally sorted. They're like, either they switch the material, or maybe they have some better design, something so significant that they can actually deploy. Let's say that happens. But it can't reach by lunar surface, as in person on a ship landing by 2030. That's not happening. Likelihood of that happening is almost zero. And SpaceX is aware of this. It's not me saying it. I'm just reading the news. This is the news. In response to latest calls, we are shared and are formally assessing a simplified mission architecture and concept of operation that we believe will result in a faster return to the moon while simultaneously improving crew safety. Basically, Starship go boom. Yeah, they know that Starship cannot work. Like, flat out, I have no idea what Elon Musk was smoking, or more importantly, who was smoking in NASA, where it's like, oh, you want to refuel this thing? Yeah, no. Again, one refueling, everybody can digest that. ULA has a concept, Blue Origin has a concept, but these are one refuel, meaning you launch one tanker, fully fueled tanker, the end. It's not like, oh, we're gonna have this and then psh, 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 psh. That's that. No. So fundamentally speaking, they know this. NASA knows this. Every engineer has been screaming about this for years, or to be fair, 5 to 6 years. But like, here's the. So let's see what happens out of this. And right now, it's going to be a very close race. NASA could force SLS to deliver things. And again, that's the whole point of SLS third launch, have crew going around the moon. They're really trying their ass off to make sure that they can put footprints on moon as quickly as possible. And let's see. But they have to let go of basically Gateway. Gateway has to go, the end. Gateway was designed on a cocaine dream, on a rocket that does not exist. It only smokes cocaine. So they have to let go of LOPG. And China has very clear advantage in short term. Let that be very clear. While all this is a mess for USA, it does have the advantage that when things are settled down, let's say by 2035 or 2040, they will have multiple companies. Ideally, even Neutron would be there. So for small technology demonstration, they will have multiple providers that can just like, hey, we can yeet technology into the lunar surface as quickly as possible. And when they need to launch some people, they should have 2 or maybe even 3 craft, if you want to count SLS, that can carry people to moon. So their pipeline is better. It's just that timeline is not good. So that is there. And it's basically Apollo 2.0 race that we are witnessing. We are witnessing basically Soviet Union and America 2.0. So instead of Soviet Union, now this is China. And this is Blue Origin's refuel system. I'm like, wait a minute, refueling is dumb. No, this is not a refueler. It's just stuff. It's basically fully fueled and launched, and it goes and parks into lunar orbit. That's it. And once the lunar craft goes there, refuels one shot, this puppy comes back to low Earth orbit, the end. And then you can refuel it in one shot in low Earth orbit. Logical, not cocaine. Logical. So let's see what happens. Again, I'm patiently waiting for third try, because again, if they successfully landed on third try on moon by March 2026, yeah, after that discussion with Starship and all that is like, cool, bro, cool story. So this was my presentation on this things that are going on. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me such movement. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.